Alright, how's everybody doing today? We're going to take a look at solving quadratic equations, this time by option number 2, finding square roots, which in our textbook is section 4.5. Your textbook might be slightly different. Now, let's take a look at our first example. Solving quadratic equations, example number 1, we've got 3x squared plus 5 equals 41. Pretty straightforward. Now notice, we only have one term, the 3x squared, that has a variable. There are no other variables, so any time that we have only one term that's a variable squared, we want to go ahead and solve it using this technique possibly. You can move the 5 over, so we're going to have 3x squared equals 41 minus 5 gives us 36. And then when we divide both sides by 3, we get x squared equals 12. Now, for the next step, we're going to square root both sides. So we're going to have x equals, now here's a technical piece. Don't forget the plus or minus in front of the square root of 12. Now square root of 12 does simplify. So we're going to have to simplify that a little bit for us. I'm going to kind of go over here on the side in case you forget. 12, what we want to do is look for factors of 12. So we have 4 and 3. Now 4 is a perfect square factor. So if I do the square root of 4, I just get 2. The square root of 3, well, that just doesn't do anything. That's still just going to be the square root of 3. So our answer is going to be plus or minus 2 square roots of 3. Now, depending on your textbook and the way things are written, that's one way you can write this problem. Here's a slightly different way you can write the solution. Some textbooks will write it like this. They might separate it and say x equals 2 square roots of 3 and negative 2 square roots of 3. And other times they might write it using this notation. They might write 2 square root of 3, negative 2 square roots of 3, and then 2 square roots of 3. They might write it like this with these braces around it. Either way is going to be okay, and sometimes they'll have the x equals in front of it, other times they won't. So that's just kind of a textbook piece and maybe a teacher preference, but all of those, all three of these things, they all mean the same thing. So check with your teachers, see which one he or she prefers, and if you're taking a test, it might be written in one of those particular ways. Just know that they all mean the same thing. Now we can go ahead and verify this in our graphing calculator, and the first thing you want to do is go to your y equals and put in the original function, our 3x squared plus 5. We want to put that side in the left-hand side of our equation, and then what we're going to do next is go ahead and make sure your window is set up the same way mine is. You want your table set up to be on ask. The independent variable is going to be on ask. Then the last thing that we're going to do is go ahead and go into our table, and to do that you hit second graph. Then you'll type in negative 2 square roots of 3 and 2 square roots of 3. Notice both of these get changed to a decimal. It doesn't stay in their radical form, but here's the piece that we really want to kind of key on right here, is that our answer, 41, matches the answer that we wanted to get for 3x squared plus 5. So once we have that solution, we verify that in our calculator, algebraically it matched, but then also when we solved it and then put our answer into the calculator to double check, we got the same thing, so algebraically we know that we did the right thing. Yay! Alright, so that's it for example 1. Now let's take a look at another example here in example number 2. Now for example number 2, I've got 1/5 times the quantity x plus 3 squared equals 7. Now what I want to do first is multiply both sides by the reciprocal of 1/5, which is just 5. Performing the arithmetic, I'm going to have just x plus 3 quantity squared equals 7 times 5 gives me 35. Now again, this time we've got blop squared, this x plus 3 part being squared. So to get rid of that exponent right here, what we're going to do again is square root both sides. So I'll have x plus 3 equals plus or minus the square root of 35. Now square root of 35 does not simplify, so with that in mind, what we're going to do then is just move the 3 to the other side. So then we'll have x equals negative 3 plus or minus the square root of 35. And again, that could be two different answers if your teacher wants you to write it like that. Negative 3 plus the square root of 35, and then x equals negative 3 minus the square root of 35. Or, again, you could write it using the braces. Negative 3 minus the square root of 35, and then negative 3 plus the square root of 35. Now, again, notice if we put it in y1, we'll end up with, we put our original function in y1, the 1/5 times x plus 3 quantity squared. If we put all that into y1, and then we go and look at our table and put in our two values, negative 3 plus the square root of 35, and then 3 plus the square root of 35, each time we get a value of 7. So yay, we did that one right too. All right, so that's it for example 2. Pretty straightforward stuff. I'm sure you guys got this. Now, before we get into our next example, we're going to take a look at an example where we're actually modeling dropping or falling objects. These are going to be the easy ones, and this isn't the only type of equation that will do this. Actually, there's a little bit more complex one, but the idea is the same here. Now, this is the equation anytime we're giving feet. All right, so this is going to be working with a U.S. metric system. The number negative 16 will be slightly different if you're working in the metric system. So for those of you taking physics, you'll know a little bit about that. Now, h is going to represent the height of the object in feet. T is going to represent our time in seconds. And then h sub 0, so that's a piece in red, that's going to be the initial height of the object in feet. So make sure you write this equation down in your notes because we're going to use it here momentarily in our next example. So hit pause if you need to, or if you already wrote it down. Let's go ahead and take a look at our next example. All right, so here we go. We've got the classic egg drop kind of problem. You have to design a container to prevent an egg from breaking. You have to drop the egg from heights of 50 feet and 100 feet. How long does it take for the container to hit the ground? So one of the first things I want to do is kind of model this, because I'm going to be up here at a certain height, and I'm going to drop the egg, splat, and it's going to land on the ground. And what I want to know is how much time it's going to take for that to happen. Now, the first thing I want to do is to kind of think about this from a common sense perspective. I drop the egg from a height of 50 feet, so that's going to be right here at a height of 0, 50. Now, when it lands on the ground, I've got no idea how much time that took, but I do know that whatever time it took, the height of the ground is definitely going to be 0. So when I go back and reread my problem, okay, I've given a height of 50 feet, and I want to know how long it takes to hit the ground, so I'm going to use the numbers 50 and 0 in the equation that we just talked about. So first thing we want to do, of course, is write down that equation. Now, after I write down the equation, what I want to do is substitute in the values 0 and 50. And the hard thing for a lot of people to do is kind of think about which one goes where. Now, the 0, because that's the height that we are at when we hit the ground, we just don't know how much time it took us to get there. So 0 is going to get substituted in for h. Now, h sub 0, my initial height, that's the height that I dropped the egg from. So 50 has to go in for that spot. Now, when you do the arithmetic, go ahead and hit pause, do the arithmetic, and solve for t. But what I want you to do when you do that is keep everything in radical form right up to the very end. So when we solve that for t, we're going to end up with plus or minus the square root of 50 over 16. Now, here's where you're dealing with some common, one of the things we're going to look at is time, and we're not going to simplify the square root of 50 over 16 into anything else other than a decimal. So then what we have, once we figure that out, we get about 1.8 seconds. Now, we don't have to worry about the plus or minus piece because time can't be negative. As much as we might like to go back in time, that's not possible, at least at this point, or we don't know how to do it. So we've got to make sure that we just use the positive square root of 50 over 16, which gives us about 1.8 seconds. Now, make sure that you write a sentence then that asks for that. All right, so we see our little sentence over here. It took about 1.8 seconds. Now, one of the key words that's in there, it's a small but subtle word, is this word about. So make sure that you use the word about or approximately, because it doesn't take exactly 1.8 seconds. 1.8 is an approximation. But also make sure you include the unit. Make sure you include seconds on there in your sentence when you go ahead and write that. So that's going to be the quick example for you for finding 50 feet. If you drop it from that height, go ahead and try it from 100 feet and see what you come up with on that one. Hit pause now, and then after you finish the problem, hit play and you'll see the solution coming up right next for you. So how'd you do with this one? Now notice this time when you square root the 100 over 16, you end up with exactly 2.5, so you don't have to use the word about or approximate. So it took 2.5 seconds for the container to hit the ground when it's dropped from a height of 100 feet. Alright, so that's it on solving quadratic equations by finding square. I hope this helps explain a little bit for you and that the process will be pretty straightforward. Alright, thanks for watching. Have a great day. Peace out.